Intro. In an audacious announcement, researchers have stated that they've uncovered a planet unlike any we've encountered before. NASA, famous for its revolutionary discoveries, has disclosed that this planet is intriguing not only because of its size and position, but also due to its emission of light that appears to be artificial. Could we be on the brink of uncovering hidden truths that might drastically alter our comprehension of the cosmos? Could this discovery point toward the possibility of life on other worlds? By delving into NASA's groundbreaking findings, we will soon unravel the truth behind this astonishing phenomenon. NASA's Dawn mission and series. In 2007, NASA launched the Dawn spacecraft with the goal of exploring some of the most fascinating objects within our solar system. Fitted with 3 ion engines, Dawn embarked on a journey beginning with a 14-month study of Vesta, the second-largest asteroid in the belt. Dawn transmitted back highly detailed images and data, shedding light on Vesta's intricate surface and varied geological history. After completing its mission at Vesta, Dawn proceeded to the second phase of its journey, one that was likely even more thrilling: a comprehensive examination of the dwarf planet Ceres. Thanks to its ion engines, Dawn could break free from Vesta's orbit and head toward Ceres, a feat that would have been impossible with conventional chemical propulsion systems. These engines provided a steady thrust, allowing Dawn to travel vast distances and enter a stable orbit around Ceres. What is this new planet? Discovered in 1801 by Italian astronomer Giuseppe Piazzi, Ceres is the largest object in the asteroid belt, located between Mars and Jupiter. For years, it was categorized as the smallest dwarf planet in our solar system until its reclassification in 2006. With a diameter of about 950 kilometers, Ceres stands as the largest and most massive body in the asteroid belt. One of the most captivating features of Ceres is its unique attributes. Scientists eagerly awaited the first close-up images of this mysterious planet, which revealed brilliant spots scattered across its surface, particularly in a large crater known as a crater. These bright spots sparked immediate curiosity and speculation within the scientific community. Prior to the Dawn mission, the best images of Ceres were blurry, low-resolution shots taken by the Hubble Space Telescope. Very little was known about this dwarf planet, and the promise of detailed observations from Dawn fueled excitement among astronomers and space enthusiasts alike. The Dawn mission aimed to enhance our understanding of the solar system's formation and investigate the role of water in the development of planetary bodies. The bright spots on Ceres, also observed on other asteroids, might be made of highly reflective materials, possibly salts left behind by evaporated water. This discovery hinted at the possibility of cryovolcanism, volcanic activity that erupts water or brine instead of molten rock. But what exactly are these enigmatic lights, and what do they reveal about the true nature of Ceres? Could they be signs of ongoing geological processes or something even more extraordinary? Ceres stands out from other objects in the asteroid belt due to its size, mass, composition, and the potential presence of water and ice. Unlike the typically rocky asteroids, Ceres has a more comet-like composition, suggesting it could unveil more secrets about the early solar system. Ceres' composition and features. After 2 years in transit, the Dawn spacecraft finally began its approach to Ceres in early 2015, marking a significant milestone as it prepared to offer the first detailed views of the largest body in the asteroid belt. As Dawn neared Ceres, the images became progressively sharper, revealing a world previously hidden from view. The initial photos showed a cratered surface, suggesting a long history of impacts. However, what drew the most attention were the mysterious bright spots amid the dark, rugged terrain. As the image's resolution improved, scientists began to formulate theories about the nature of these spots. Were they areas of ice reflecting sunlight, or could they be something even more remarkable? Speculation ranged from mineral deposits to possible signs of cryovolcanic activity. To everyone's astonishment, closer examination showed that the brightest spot wasn't just one feature, but a collection of distinct areas. The most widely accepted explanation was that these were salt deposits left behind after water sublimated. This suggested that Ceres had, or possibly still has, some form of geological activity capable of pushing water or brine to the surface, where it rapidly evaporates, leaving behind bright reflective residues. These findings challenged previous ideas about Ceres, painting a picture of a more dynamic and intricate world than anyone had imagined. The potential existence of subsurface water or brine pockets could have profound implications for our understanding of the possibility of life elsewhere in the solar system. Ceres is often described as an icy world with a rocky yet porous surface. Unlike most asteroids, which are largely composed of rock and metal, Ceres stands out for its distinct composition. Its surface is a blend of water ice and hydrated minerals, including clays and carbonates, giving it a less dense structure than its rocky neighbors. This composition suggests that Ceres may harbor significant amounts of water beneath its surface. Its outer layer is rocky but porous, with trapped ice and other volatiles, making it resemble a comet more than a typical asteroid. Cryovolcanism on Ceres. Cryovolcanism is an intriguing and relatively rare geological process, especially when compared to the familiar volcanic activity on Earth. Unlike traditional volcanoes, which expel molten rock, cryovolcanoes, also called ice volcanoes, release materials such as water, ammonia, or methane. These substances can remain in liquid or gas form in extremely cold environments, where they exist as cryovolcanic activity. On Ceres, cryovolcanoes allow salty water to rise to the surface. When this briny water comes into contact with the vacuum of space, it quickly sublimes, turning from solid or liquid into gas. This process leaves behind glowing reflective salt deposits that form the mysterious bright spots visible on Ceres. The most famous of these spots is located in the crater known as a crater, specifically the spot referred to as Spot 5. This area has attracted significant attention due to its high reflectivity and periodic changes observed by dawn. These fluctuations are believed to be the result of water sublimation, suggesting that cryovolcanic activity might still be occurring or may have happened recently on Ceres. In addition to Spot 5, Ceres hosts several other bright spots, each with its own distinctive characteristics. These spots aren't confined to one location but are spread across the surface of the dwarf planet, indicating that cryovolcanism could be a widespread phenomenon on Ceres. The presence of these bright spots highlights the dynamic and active nature of Ceres, challenging the previous belief that it was a geologically dormant world. As the Dawn spacecraft continued to send back more detailed images, it revealed a surface marked by a variety of craters, each telling a unique part of Ceres' history. The discovery of these features on Ceres truly revolutionized the way we view this dwarf planet. With its icy composition and signs of possible cryovolcanic activity, Ceres challenges many of the assumptions previously held about bodies in the asteroid belt. No longer considered simply a frozen relic, it is now seen as an active and evolving world. Could there be life on Ceres? The bright spots, particularly in the Achater crater, continue to generate curiosity among scientists, as they might be a glimpse into processes that are not only geological but potentially linked to the planet's ability to harbor liquid water. The study of Ceres has far-reaching implications beyond just understanding this particular dwarf planet. By examining Ceres' internal composition, surface features, and the nature of its bright spots, researchers can gain crucial insights into the broader dynamics of icy bodies in the solar system. The materials found on Ceres, water ice, ammonia, clays, and salt deposits, could offer valuable clues about the chemical makeup and environmental conditions of other similar celestial bodies in the solar system and beyond. Moreover, the potential for cryovolcanism on Ceres opens up exciting possibilities regarding the broader geological activity of icy moons and dwarf planets, not just within our own solar system but on exoplanets as well. It suggests that environments we previously thought to be static or inhospitable might, in fact, be dynamic and capable of supporting complex processes. What scientists are saying adult. Could this also mean that other distant worlds, once thought to be frozen and lifeless, could harbor conditions conducive to life? NASA's Dawn mission continues to stand as a testament to the power of space exploration. The data it has returned has already reshaped our understanding of the solar system's formation and evolution. As we probe deeper into the mysteries of Ceres and other distant bodies, each discovery adds a piece to the puzzle of how planets, moons, and other celestial bodies evolve over time. For now, The bright spots on Ceres remain one of the most intriguing phenomena in our exploration of the cosmos, but they are only the beginning. As technology advances and more missions are launched, the possibility of even greater revelations looms large. Ceres, which once seemed like an obscure and forgotten dwarf planet in the vast asteroid belt, now stands as a beacon of mystery and potential. Its surface, its internal structure, and its enigmatic bright spots may one day provide the key to understanding the early solar system and the processes that led to the formation of planets and other bodies. The potential for life, or the ingredients for life, on Ceres remains an exciting possibility that continues to inspire researchers and space enthusiasts alike. As we continue to explore Ceres and other distant worlds, the line between science fiction and reality continues to blur. The idea of life on other planets, once a subject of speculation and imagination, is now a real and serious question. Could microbial life exist in the underground water pockets on Ceres? Could the conditions on other icy moons in our solar system be suitable for life as we know it, or even life that we've yet to imagine? These are the questions that will drive the next wave of space exploration and may eventually unlock the mysteries of the universe. Final thoughts and outro. In the years to come, as we look to send more spacecraft and possibly humans to explore these distant worlds, the discoveries of Dawn and future missions will shape our understanding of what is possible in the universe. From Ceres' icy surface to its bright spots that may point to the presence of liquid water, the dwarf planet stands as a reminder that there is still so much we don't know about our solar system and the many wonders it holds. The mission to explore Ceres is far from over, and with each new discovery, we come closer to uncovering the secrets of this fascinating world. Let me know what your thoughts are about the findings on Ceres in the comments below. If you found this video fascinating, don't forget to hit the like button and subscribe for more updates on the latest space missions and discoveries. As more data from the Dawn mission continues to arrive, scientists are only scratching the surface of what might be learned about Ceres. The bright spots, in particular, have sparked not only scientific curiosity but also public imagination. Their mysterious nature raises more questions than answers, fueling ongoing research and investigation into the possibility of further geological or even biological activity. The fact that these spots are spread out across the surface suggests a systemic process at work, and that something significant is happening beneath the surface, potentially involving water or briny materials that could create the ideal environment for future exploration. While the Dawn spacecraft has already made great strides in unveiling the wonders of Ceres, there is still much left to discover. As technology advances, we can expect even more detailed images and measurements that will further refine our understanding of the planet. This will allow scientists to test existing hypotheses and perhaps develop new theories based on new findings. Every new image or piece of data sent back from the spacecraft brings us one step closer to uncovering the full story of this icy dwarf planet. As we continue to probe Ceres and other distant celestial bodies, the broader implications of these discoveries begin to come into focus. The prospect of life or the ingredients for life existing on Ceres challenges our current understanding of where life could potentially thrive. Traditionally, scientists have looked for liquid water, the fundamental requirement for life as we know it, on planets and moons within the habitable zone of stars. However, Ceres' surprising revelations suggest that even in the coldest, most distant corners of the solar system, conditions might exist for microbial life to take hold. The presence of water ice, salts, and other organic compounds, combined with evidence of cryovolcanism, opens up the possibility that Ceres and other icy bodies could harbor ecosystems far different from anything we might find on Earth. Exploring the potential for life on Ceres also leads to further questions about how life could adapt to such extreme environments. On Earth, life has been discovered thriving in the most inhospitable places, from the depths of the oceans to the hottest volcanic vents. If life can survive in such diverse conditions, what about environments we have yet to explore? Could microbial life on Ceres, if it exists, be so radically different from Earth's life forms that it would be unrecognizable to us? This is a question that future missions might be able to address as technology advances and space exploration capabilities expand. Furthermore, the study of Ceres could offer new insights into the origins of our solar system and the early conditions that led to the formation of planets and other bodies. The materials found on Ceres, such as hydrated minerals and ammonia, suggest that it might have originated farther out in the solar system before migrating inward. This theory could offer a new perspective on the migration of celestial bodies and the ways in which they interacted with their environment. Understanding Ceres' history could provide essential clues about the early solar system's dynamics and how the conditions for planet formation arose. The unique composition of Ceres also holds promise for understanding how life-supporting environments might form on other planets and moons in the far reaches of space. If Ceres was able to retain enough water beneath its surface to allow for cryovolcanism, it may hold a reservoir of subsurface water that could be tapped for future exploration. This discovery could spark further investigations into similar bodies, such as Europa, Enceladus, and Titan, which have also been identified as prime candidates for hosting life. Ceres' potential as an ocean world expands the horizons of our search for extraterrestrial life, showing that habitable environments could exist in the most unexpected places. In addition, the findings on Ceres raise questions about the role of water in shaping planetary bodies and the long-term sustainability of ecosystems. As more detailed data is gathered, researchers may be able to determine the extent to which water played a role in shaping the dwarf planet's geological features, including its unique surface composition. Such insights could help us better understand the processes that govern the development of planets and moons and their ability to support life. The future of planetary exploration lies in examining these distant worlds, unlocking their secrets, and using their stories to learn more about our own planet and the potential for life elsewhere in the cosmos.